So today we're going to be looking at multiplying matrices. We're going to start with a little bit of review of scalar multiplication, which might help on the delta math if you're still working on that from yesterday. So just to kind of recall from what we've seen, scalar multiplication is if you have a number on the outside and you simply just multiply everything inside. So for this first example, they already did it for you, like 2 times 5 is 10, negative 3 times 5 is negative 15, and so on. So if you see a number outside a matrix, like a single number, just basically distribute it in. But let's look at an example together. This is kind of like what you were doing in the delta math. Some of them had fractions. If you do see a fraction in the delta math, just remember if it's like 1/3, you're going to divide by 3 to everything inside. If it's 1/2, you're going to divide everything by 2. So if you see a fraction, you're going to be divided by that denominator. But let's look at the problem at hand. So we have 2c plus 3d. So we're going to have 2 times our C matrix plus, and we're going to have 3 times our D matrix. So from what we've seen, we're just going to multiply this out. So like 2 times everything in this one. So if we do that, everything's just going to double. So I'm just multiplying everything in this matrix. Trying to draw an arrow. Okay, that's a fail. All right, no arrow. So that's our answer there. And then for the second matrix, we're going to multiply everything by 3. So that would be just tripling everything. So 15, negative 3, 0, and 9. And then to get our final answer, we just add these matrices together. So 2 plus 15 is 17. 8 plus negative 3 is 5. 4 plus 0 is just 4. Negative 4 plus 9 would also be 5. So that's our answer. And that's what we've seen up to this point with multiplying. But today we're going to be looking at like kind of our big concept for today is if we have 2 different matrices, how do we multiply them together? We're going to see it's maybe not how you would expect. And it can, I'm going to be straight up with you, it can be a little bit tedious or it can look kind of confusing at first, but once you get it down, it's just a process. So I promise you, like, even if you walk out of today's class and you're like, I don't know what the heck I'm doing, stick with it. Once you get it down, I mean, you will do well with this. That's usually how it goes every year we do these. And just a heads up for people in here, for some reason, my chat box isn't like popping up. Oh, there it is. Okay, so now I can see your chat. Okay. But if not, just say something if I don't respond to what you put in the chat. But let's look at multiplying matrices. To save you a little bit of time or to save you having to see my crappy handwriting, these are the steps. The first thing we're going to look at is figure out the dimensions of our matrices. The second step is we're going to check if the inside numbers match, because that lets us know if we can multiply. Some problems you'll see you can't multiply, so you just write impossible. Our third step is we're going to look at the outside numbers of the dimensions to figure out what the size of our answer or our product will be after we're done multiplying. Kind of remember product, if you don't know, that's like the result you get after multiplying 2 numbers. So for example, 5 times 2, 10 would be your product. So if you ever see the word product, that just means the answer you get after multiplying. But let's look at these 4 examples. So the first thing you always want to do is you want to check the inside numbers. So we have 2 and 2. So are the inside numbers the same? Yes. What that means is we would be able to multiply if we had a 3 rows, 2 column matrix and a 2 row, 4 column matrix. To see what your answer would look like, you look at the outside numbers. So for example, our answer would be a 3 by 4 matrix, because that's the outside. So let's look at another one, then I'll have you guys try. But if your inside numbers don't match, so see how we have a 3 and a 2 in the second problem? Since they don't match, well, you don't have to worry about what the size of your matrix will be because there wouldn't be a matrix. You can't multiply a matrix with 2 rows and 3 columns by a matrix with 2 rows and 3 columns. Once we actually do the multiplication today though, if you actually try to do this, you would kind of realize as you're going through it, something's off. You would probably like something would feel off and you'd probably realize that. But it can save some time if you just check it quick. So to the class, who we have in here right now, for this next one, are our inside numbers the same? You can either say it or in the chat.
Yeah.
So they are. So what's the dimensions of our answer going to be?
2 and 1.
It would be a 2 by 1 because that's what the outside would be. And thank you. I think that was Mari, I believe.
No, I think that's Theo.
Oh, it was? Okay. What about the next one? Are the inside numbers the same?
Yeah.
They are. So what would the size of our answer matrix be?
3 by 2.
It'd be a 3 by 2, looking at those outside numbers. So that's going to be kind of our first step when we're multiplying. So we're going to do 3 examples of multiplying. They take a little bit of time. They're tedious. I'm going to be straight up with you. I mean, it can be annoying to do these, but keep in mind, it's not hard. You're just going through some steps, going through a process. It's not that bad, especially once you get used to it. You can go pretty fast with them. But it is kind of, at first, it can seem like it's a ton of work. But let's look at our first one. Let's see your opinion. Let me not skew it too much. So the first thing you want to do is look at the dimensions of our matrix. So like, for example, this first one, we have 2 rows like going across, and we have 2 columns. So our dimensions, it's a 2 by 2 for the first one. I mean, if you look, the second matrix is the same. It's got 2 rows going across, and it's got 2 columns going up and down. So it's also the 2 by 2. So since the inside numbers match, that means yes, we can multiply these. The outside tell us the dimensions or the order of our matrix. I'm just going to put DIM for dimensions because I don't have enough space to write it, or I don't want to write it all out. So we're going to work this out. We're going to see it's not maybe as simple as you might think. You might think you just multiply, for example, like the 3 times the 4, the 2 times the 2. That's not how you multiply matrices. We're going to have to look at the rows and columns. So I'm going to draw like a giant matrix just because I need space because I write big. So our answer is going to be a 2 by 2 matrix. So we're going to have these 4 spots in our matrix. So here's how we do this. One thing to keep in mind is we always look at the rows for the first matrix and we look at the columns for the second matrix. So we start with the first row and we start with the first column. So the first thing we do is we take the first number in the first row, in the first number in the first column, if I can keep my words straight. I'm going to use the different colors maybe. It's easier to see. So we're going to do 3 times 4 plus, then we look at the second number in the row times the second number in the column. So it'd be 2 times 1. So now we're done with the first row and the first column. What we're going to do next is now we're going to look at the second column. We're still looking at the first row, but now we're going to multiply it by the second column. So for example, for this one, we would still, our first number would still be 3 in the row. Now our first number in the column is 2. And then we're going to add, you always add between these products. We're going to add the second number in the row, so it's still 2, times the second number in our column, which would be 3. Now that we've multiplied the first row by all the columns, we're done with it. Now we're going to do the same process, basically exactly what we just did, except now we're going to start with the second row. So we're going to do the second row and the first column. So the first number would be 1 in the row, and the first number in the column would be 4. So it'd be 1 times 4. Then the second number in the row is 0, and the second number in the column is 1. So it'd be 0 times 1. So now we're done with this column. So now we're going to look at our last column. Let me see how we're doing. Well, what's the first product we're going to have? So our first number in our row is 1. What's the first number in the column? Like, what are we going to multiply this 1 by?
2.
2. Then we're going to add, what would our second product be? What are we going to multiply the 0 by?
3.
The 3, right? So I know right now this probably seems a little bit weird, but trust me, you'll get more used to it. So the last thing we need to do to get our final answer is we just need to work out what we wrote out. So for example, so our answer is still going to be a 2 by 2 matrix. Hopefully I can squeeze in our answer. It should. We're going to like just work out what these equal, and you could either do it in your head if you're pretty good at mental math, or you could even just plug these in a calculator. So 3 times 4 is 12, plus 2 times 1 would be 2. That would be 14. Then we're going to plug this piece into our calculator or work it out in our head, like whatever's easiest for you. 3 times 2 is 6, plus 2 times 3 would also be 6, so add those together, you get 12. We would figure out what this piece equals. Well, 1 times 4 is 4, 0 times 1 is just 0, so that would be 4. And we're going to plug this last piece into our calculator or work it out in our head. 1 times 2 plus 0 times 3 would be 2. This is a second chance to see it, or if it's starting to come, just another chance to kind of reinforce it. So like I said, the first thing you always want to do with these problems, though, is write your dimensions. I mean, it's the same as what we just saw in example 5, but you have 2 rows, you have 2 columns, and that's true for both of these, actually. So you have 2 rows going across and 2 columns. So it's still a 2 by 2. Oops, I don't know why I did that. Left so much space. 2 times 2. So the inside numbers match. That means you can multiply. The outside numbers tell you what your answer is going to look like. So I'm going to just, once again, because I write big, I like to give myself a lot of space to kind of write these out. And one thing, when you're kind of doing these on your own or you get more comfortable with these, if you don't want to write everything I'm writing in this big matrix, if you kind of want to just plug that in your calculator as you go and just write your answer, that's something you can work towards if that is easier for you. So, I mean, there is some flexibility, but especially when we're first learning, I'm trying to write like everything you're doing. So hopefully it's clear or you can kind of figure it out. But if you do find some shortcuts or you don't need to write everything out, that is totally acceptable when you're working on these on your own. So like I said, though, we're going to be looking at the first row, and we always look at the columns in the second matrix. You always start with the first row and you work your way through the columns, and then you go to the next row, work your way through the columns, so on and so on. So for this first one, maybe I'll do this one just to make sure we're on the right track. So we have our first number is 1, our first number is 2, so we multiply those together, and then we add our product of the second set of numbers. So 2 and 1 would be the second number in the row, second number in the column. So now we're done with that column. We'll move on to our second column, still using this first row. So maybe someone either in the chat, you could type it, or feel free to shout it out. What would be our first product in this? We're looking at this box here. Does anyone know? One and one. Sorry, you're cutting out a little bit, but I believe it sounded like 1 and 1, right?
No, but
Oh, that's not what you said. Oh, what did you say? I'm sorry.
I said 2 times 1.
Okay, the reason it's 1 times 1, just because, sorry, I thought you did say 1 by 1. It was kind of hard to hear, but because the first number in this row is this one, and the first number in the column is this one. So then you do the second number, so 2, and the second number in the column would also be 2. So now we're done with this row. We took it times each column. Now we're going to move to the second row. So let's see if we can do this one. And I'll try to make sure I hear what you're saying. I'm sorry. So you look at the second the second row, and you're looking at the first column. What would the first product be?
3 and 2.
3 times 2? Because that's your first number is the 3, and your first number is the 2. All right, what would our second product be?
1 and 1.
1 and 1, because these are both the second number in the row and column. So now we're done with that column. We're going to move on to the final column, because we haven't multiplied this row by it. What would our first product be? It's going to be 3, because that's still our first number in the
3
row.
and 1. 3 times 1.
3 times 1, good. Seems like we're starting to at least get more used to the process. All right, what would our last, so what are we going to add? What's our last product going to be?
1 times 2.
1 times 2, perfect. So then you just need to kind of put this in a calculator or just kind of work it out in your head, depending on what you're comfortable with. So if you just work this out, 1 times 2 plus 2 times 1, that would be 4. For this one, just plug this in your calculator. 1 times 1 plus 2 times 2 is 5. Plug this in. 3 times 2 plus 1 times 1 would be 7. Then plug this one in. 3 times 1 plus 1 times 2 would be 5. And if you want, you could kind of work these out as you go, or you can do it how I'm doing. I kind of usually just do it at the end, whatever is easiest for you. But depending on how you are, some people, once you get more comfortable with these, you won't have to write this out. You'll just kind of put it in your calculator as you go. And that's an option. Maybe we can try and do that for this next problem so we don't have to write as much, because I've been trying to write out problem 7 all day, and it's a lot to write. So if we can save some writing, it might be helpful. Even when you're doing your delta math and stuff, it might help save you some time. So I'm going to try that with this class. We'll see. Maybe it'll blow up in my face, but it's worth a shot. So the first thing we want to do, though, like in all these problems, is figure out our dimensions. So this one has 3 rows, and it has 2 columns. So that's a 3 by 2. The second matrix has 2 rows, and it has 3 columns. So that's a 2 by 3. So our inside numbers do match. So all the problems today have worked, but you will come across some problems where they don't. So our answer is going to be a 3 by 3 matrix. So this one's a doozy. This is probably the worst you'll ever see in this class when it comes to matrices. Is this like where you have a product that's going to be a 3 by 3. So let's see if we can do this without having to write every step out. I don't know if you guys have a calculator like handy or if you're just using your phone, but we're going to start with the first row. And we're going to look at the first column. Let's just put this in our calculator. Remember, so you take the first number times the first number, so 4 times 1, plus the second number times the second number. So So what do you get if you do that product? I mean, does anyone have a calculator handy? What's 4 times 1 plus 2 times 3? Did someone say it?
10.
Because you should get 4 plus 6 if you worked it out in your head or if you put it in, but that's 10. So this is an option. I don't know if writing it all out helps you get everything right, but this might be something you want to work towards because honestly, myself, I hate writing out everything I'm adding and multiplying. It's tedious. So if we can make this process just even a little bit less tedious, I'm sure that's welcome. So we're going to use the same row. Now we're going to look at the second column. So now we're going to do 4 times 0 plus 2 times 4. What would that be? I'll do this. I'll take this one. This one's 8. 4 times 0 plus 2 times 4. Let's look at our next column. So remember, you do the first number, so 4 times 2 plus 2 times 1. It's different, but you get the same answer as the first one. 4 times 2 plus 2 times 1 is also 10. So now we're done with the first row because we took it times every column. So we don't have any more columns to look at, so we're done with it. So now we're going to kind of repeat the process, but we're going to look at the middle row. So we'll start with the first column. You'll do the first number times the first number plus the second number times the second number. And one tip, if you ever see a 0, you can kind of skip that because this would be 1 times 1 plus 0 times 3, but 0 times 3 is just 0. So the only thing that really matters in this part is the 1. So our answer is going to be 1, but you could plug it all in. But if you ever see a 0, it kind of just cancels out. So if you see a lot of zeros in your matrices, that's usually a good thing. It can save you a little bit of time when you're plugging it in or working it out. So now we're going to look at our second column. So it'd be 1 times 0 plus 0 times 4. Well, that's just going to be 0. We move to our last column for this row. So our first number would be, it'd be 1 times 2 plus 2 times, or sorry, not 1 times 2 plus 0 times 1. So sorry, I'm misspeaking, but that would just be 2. So we've taken the middle row, we've multiplied all 3 columns. Now we're going to go to our final row and redo the process. So last row, first column. We'll see these ones get a little bit bigger, if I remember right, because we'd have 6 times 1 plus 7 times 3. So if you plug that in or work it out, that would be 27. Then we'll go to the middle column. It would be 6 times 0 plus 7 times 4. So that would just be 28. Then we just got to do the final row. I mean the final column in the final row. So that'd be 6 times 2 plus 7 times 1. So if you plug that in or work that out, that should be 19. So if this is something you can handle with just kind of plugging it in as you go, this is totally acceptable. If it's easier to write it out like we did in these examples, do that. I mean, whatever process works for you, that's what you're going to kind of want to work towards. But I know some people, this is almost easier to do like in number 7 because writing all this almost makes them kind of get more lost in the process. I find sometimes writing too much can also throw us off. So it kind of depends on what works for you.